Hi everyone, my name is Michael Stewart. I'm here from the University of Western Australia, here to present our work on cleaning and visualization of unstructured text in safety records. So unstructured data accounts for a huge proportion of data in organisations, approximately 80%. And textual descriptions are a vital component of capturing information in events, especially in the context of incident investigations and other safety records. So here we have a few different examples of some safety records. So typically there'll be a whole bunch of different structured fields. For example, we've got the date, the number of days off as a result of this particular injury, the severity of the accident, and then we also have a description. This is the unstructured portion of the data. So for example, this one's walking in car park from office to workshop and rolled ankle. You can see there's a lot of really valuable knowledge captured in that text. And really what we're interested in in the natural language and technical language processing group at UWA is this technical language. It's essentially short text where a domain expert has written down some really crucial kind of information pertaining to something in the industry. So the motivation behind this work is that accident reports are often analysed statistically, but the accident descriptions are very rarely used for any kind of analysis at all, despite the fact that they contain such a wealth of really valuable information. By unlocking the knowledge buried within these descriptions, it's possible to obtain insights into hazards, injuries, and contributing factors. So there are a few challenges associated with technical language. Firstly, it's rife with different kind of challenging things such as spelling errors, acronyms, and domain-specific terms. And while there are quite a few different processing toolkits available for processing these descriptions, such as NLTK and GATE, these tools require a huge amount of programming experience. You essentially need a computer science degree to be able to use them, which means that domain experts can't use them directly. This is a major benefit for domain experts to be able to benefit from these kind of toolkits. So in light of these challenges and motivation, we introduce Aquila, a knowledge discovery tool. Aquila is a web-based tool for being able to visualize and analyze technical records. It's designed to be usable by anyone. There's absolutely no programming experience required. And it features a range of unique visualizations that support knowledge discovery. It utilizes a range of techniques from technical language processing in order to clean, process, and visualize event-based data. And Aquila is structured around traditional data mining milestones, such as exploratory analysis and association rule mining. And now I'd like to present a demo of Aquila. So here we have the dashboard of Aquila. So the first visualization I'll show today is the timeline. So in this data set that I've uploaded here, we have a safety data set containing safety records from approximately half a year. So from July 2013 through to December 2013 from the Australian mining industry. And each of these little dots here in the timeline represents a particular event, so an accident in this case. So you can see on July the 1st, 2013, we had 2 different accidents. You can hover over these to get an idea of what they were. For example, we hover over this one, we can see the exact description of what happened. So this tool allows us to get a really good idea of the landscape of our data. We can have a look, we can see how many accidents occurred over time. And they're color-coded based on the severity in this case. So the yellows are serious, blues are minor, greens are non-disabling injuries, and the reds are fatal. We can also aggregate this visualization up the top. So right now we're looking at the daily accidents that have occurred. We can also go ahead and go to weeks. So now we can get a weekly report of these accidents, months, and of course years. The second visualization is a word cloud. Essentially, it shows the most prominent phrases in the dataset. So on the left, we have the noun phrases. So these are sequences of one or more nouns together, which is more useful than words because quite often the important terms will actually be multiple words long. So injured person is by far the most prevalent in this particular data set. We also have ones like worker, the machine, medical center, and so on. And on the right, we have the relation phrases. So these are the commonly sequences of one or more verbs between the noun phrases. Things like causing, was assisting with, and so on. So down the bottom, we can actually go ahead and scroll here. This essentially shows how these terms evolve over time. So our data set has approximately 750 or so records. So we can see if we only add the first 100 records, we can see how these terms kind of evolve as we go through and add more and more records. So we can see that injured person starts off relatively the same frequency as all the other terms, but over time it becomes more and more prevalent. And we can also do this with the relation phrases. Now the third visualization is the entity recognition report. This essentially shows us all of the important entities in our data set. So on the left, we have a whole bunch of different categories here. So age group, gender, severity, body part, and so on. And on the right, we have our documents, well, our accident reports that have been tagged using these entity types. For example, crash injury here has been labeled as a crash injury, which is a subclass of injury. Head and chest have been labeled as head and chest, which are subclasses of body parts, and so on. And what this allows us to do is filter these reports based on a particular entity class. For example, if we're interested in looking at reports pertaining to, let's say trucks, for example, we can go into vehicle, go into heavy vehicle, and at the moment we've got, let's say, the dump truck category. We'll have a look at that one. So these are the reports that are now filtered, and these reports are the ones that contain dump truck. You can see we have 38 entries here. And of course, this bar chart on the left actually shows us the number of times each of those things occurs. So we can get an idea of how each entity compares to each other entity. Now, the next visualization is this entity linking graph. We essentially construct a graph from each of the reports using the entities that appear. So each of these nodes in this graph represents a particular entity class. And these nodes will be linked to other nodes when they appear in the same document. For example, if light vehicle or any of its children were to occur alongside the age 25 to 34 group, there would be a link in this graph. So we can move around with the graph using the mouse, and we can click on a particular node in order to show how that node relates to other nodes. For example, if I click on pump here and hold down, I can see the number of times pump has appeared alongside other entity types. So we can see there have been 15 injuries if you just look sort of directly above the pump node, and burn has a frequency of 4, which shows that pumps and burns are quite strongly linked in this particular data set. We can also go ahead and click on some different body parts as well to get an idea of the accidents that have occurred alongside the body parts. So for example, left leg is commonly associated with 8 injuries, 1 fracture, 1 break, 1 contusion, and so on. So it really allows us to get a strong idea of exactly the relationships between variables in our data, allowing us to obtain insights into the causes behind, or insights into sort of injuries and their contributing factors in our data set. And the final visualization I'll show today is the association rule mining visualization. This one visualizes the association rules in our data set. So for example, when operator, serious, and haul truck occur together, that is a strong predictor of it being associated with neck and back. Basically what this means in English is that operators involved in serious accidents who are driving a haul truck commonly tend to injure their neck and their back. So the association rules are here on the right. Once again, we can filter them using the entity chart on the left. So if we were interested in rules pertaining to a particular entity type, let's say we go into vehicle, heavy vehicle, and haul truck, for example, we can see all of the association rules associated with haul truck. So we have the antecedent, the consequent. The lift allows us to sort of bring all the most important rules to the top. And then the confidence is essentially the ratio of the consequent occurring alongside the antecedent. So in this case, it occurs 62.5% of the time, which is quite high. So this visualization is another really important visualization for being able to understand the relationships between entities in our data. Okay, so in conclusion, in this presentation, we've presented Aquila, a powerful web-based tool for visualizing and analyzing technical records. It enables owners of event-based datasets, such as occupational health and safety officers, to identify latent knowledge in their data with no programming experience and minimal effort. Thank you very much.